Hello and welcome to our video on a tree diagram example. And I will just start off and say, if you could define your events, set up your tree, and answer every single one of these questions consistently, then I would consider you an expert, okay? And that's a good thing. So let's see if we could do this. It should take about 10 to 15 minutes, maybe sooner. So first of all, let's talk about the problem. Leah is flying from Boston to Denver with a connection in Chicago. The probability that her first flight leaves on time is 15%. If the flight is on time, the probability that her luggage will make the connecting flight is 95%. But if the first flight is delayed, the probability that the luggage will make it is only 0.65%. So if that first flight's on time, she has a pretty good chance of getting her luggage. But if that first flight is not on time, then the chance that she doesn't get her luggage is pretty high. So let's talk about events. There's only two events that are happening. It's very similar to the last thing that we did. There's only two events, okay? And we'll do OT, okay? This means that the first flight is on time, okay? So if the first flight's on time, what else could happen? We'll call OTC first flight was delayed. Okay, this is the hardest part. It's defining your events and setting up your tree diagram. Once you have the tree diagram made, really easy to find all these probabilities. Okay, so the second event. Okay, so probability that first leaves on time is 15%. So what else could happen? She's either going to get her luggage. She's either going to get her luggage when she shows up, or okay, she won't get her luggage. So I'm going to call that get luggage. This is she receives luggage. Let me see if I'm doing that wrong. I before E, set before C. She receives, that doesn't look right. She receives luggage when she gets to her final destination, or GLC is no luggage. Okay? Okay, so here's our tree diagram. And I'll do it straight lines. I'll do the first one in straight lines. Okay, so the first thing that's going to happen is she's going to, remember, you have to split up your events. You have to split up your events. It's very important. Okay, so here's where we start. You're either going to, when she shows up to that airport, there's two options. She's either going to make the flight or she's going to miss the flight. What's the probability that she leaves on time, that flight was on time? Okay, that was 15%, so that would go here, 15%. Okay, that's the probability that it's OT. Okay, so if she shows up, she has a 15% chance of making it, and then 85% chance of not making it. Okay, so let's do the next one in a different color. So I'm just going to do two like this. Okay, and that's that, and that's this. So this was on time, and this is going to be whether she gets her luggage or not. The whole thing. And I got to leave some space down here, so this is the second one is get luggage. Okay, so think about it. They gave you this, and we were able to find this. Now the next thing they're going to do is they're going to give you one of these and one of these. So they say if the flight is on time, the probability that her luggage will make the connecting flight in Chicago is 95% if it's on time. So look, what path did you have to take? This path or this path? Okay, well, you took the top path. So the probability that you get the luggage given the first flight was on time is 95%. Okay, so this is you get the luggage given you're on time. So this one here would be you don't get your luggage given it was on time, because both of these are on time. And if this is 95, that's going to happen 5% of the time. Okay, so that's the top. For the bottom, this bottom, if you take this path, that first flight wasn't on time. Okay, so this is going to be two different things. She's either going to get her luggage or she's not going to get her luggage. Okay, so this is the probability that she gets her luggage given the first flight was delayed. And then the other option is the probability that she doesn't get her luggage given the first flight was delayed. Okay, so this one here is, okay, she got to live and get the luggage. So let's see what they give you. They give us one of these two. You have to read the problem and figure it out. But if the first flight is delayed, okay, so this is that way. If is a conditional. If the flight's delayed, so I want to go down this way. If it's delayed, the probability that the luggage will make it is only 65%. So that's the probability she gets her luggage given it was delayed. So that is 0.65. Okay? So if that's 0.65, I know this plus this has to equal 1. So I could do 1 minus this to get this one right here. Okay, so that's going to be 35. Okay, so now that you have your tree, one good way is to find all the ands and have all the ends there. Okay, so that's whatever I do it, I set it up and I go ahead and find everything, so then I can answer all my questions really quickly. So if I take this path, if I take the top path, that would be the probability that it's on time and I got my luggage. So that's going to equal, I'll just do it out, 0.15 times 0.95. Okay, the second route would be this. The second and would be this route right here. The flight was on time and I didn't get my luggage. The flight was on time and I didn't get my luggage. The probability that my flight was on time and I didn't get my luggage. So that's going to be 0.15 times 5. And I'm going to show you like another way that you could look at this if you like percentages. Okay, so this one, this route, the next route is going to be, okay, you showed up and your flight wasn't on time, or yeah, your flight wasn't on time, but you still got your luggage. Flight wasn't on time, but you still got your luggage. Okay, so that's going to be the flight wasn't on time, but you still got your luggage. So that's going to be 0.85 times 0.65. And the last one, the last path, is going to be you showed up and that first one was delayed. Okay, so then you eventually got there and you didn't have your luggage. That's the worst, right? Oops, what am I doing? So it's the probability that you were delayed and then you did not get your luggage. So that's going to be 0.85. Now listen, you don't have to write all this notation. You could just put these numbers there. I'm just writing the notation to kind of show you what's going on. 0.35. Okay, so let's go ahead and I'm going to pause it and then I'm just going to write all these numbers in there to save some time. Okay, I'm back. So these were all my numbers for my ands. Okay, so it's very important whenever you set this thing up, you want to do some checks to make sure you didn't make any mistakes. You want to add these two, make sure it's 1. You want to add these two, make sure it's 1. And you want to add these two and make sure that they're all equal to 1. Okay? You also want to add these 4. These are all disjoint events. They all have no overlap, okay? So we're allowed to add them. These are ORs. What's the probability of this or this happening? Okay, so you want to add these up to verify. So 0.1425 plus 0.0075 plus 0.5525 plus 0.2975 equals 1. Okay, so I verified it and they all equaled 1. Now I'm set to go. Find the probability you get your luggage given you were on time. So this is a good one because this should always be the first and this should be the second. If it's not, then it's more difficult. Okay, the probability of the second given the first happened. So that would be this one up here. So the probability of that is 0.95. What's the probability you didn't get your luggage? So that's on here too. The probability I didn't get the luggage. The probability I got the luggage was 15%. So 1 minus 15% is 0.85%. Or not 0.85%, but 85%. Okay? We'll find the probability that it's on time and you got your luggage. So if it's an and on a tree diagram, we multiply down paths of the tree. Okay, so on time and you got the luggage. So that would be this path right here. On time and got the luggage, so that would be 0.1425. I'm going to try to go through this fast. What's the probability that you were late and you got your luggage? So that's this path right here. You're late, but you got your luggage. So that's 65%. Oh, I'm sorry. That's right here. You were late and you got your luggage. That's 5.525. Okay, what's the probability you got your luggage? Now this is a little tougher because that's not here and it's not here, and this is it. This is probably you got the luggage given you were on time. Okay, well these events are probably not independent. If they were independent, it would be 95%, but that's not going to be the case. These are not independent events. Okay, and this is a good test. So the probability you got your luggage? There's two ways that you could get your luggage. The flight was on time and you got your luggage, and the flight was late and you got your luggage. Okay? So what you need to do is, since these are disjoint, you're allowed to add these two. You're allowed to add the two ways that it happened. So you need to add that with that. Okay? So make sure you're really clear on that. That's where it starts getting a little more difficult. Okay, so that's 0.695. What's the probability that you didn't get your luggage? Okay, so if you look at it, if you got your luggage was 95%, we could use our complement rule here. 1 minus the probability that you got your luggage. So that's just 1 minus 0.695. Now remember I taught you the complement rule? Watch how this goes. 6 plus what gets you to 9? 6 plus what gets you to 9? 3. 9 plus what gets you to 9? 0. 5 plus what gets you to 10? 5. That's the complement. Now look, there's another way to do it too. There's two ways you cannot get your luggage. You could be on time and not get your luggage, or you could not be on time and not get your luggage. If I add both of these, I should get this number, and you could see it. This is 29, so 0.2975 plus 0.0075. Okay, look at, they match up. I'll have to keep that in there. Let me do that again. I was off the screen. Okay, so if you look at it, I use the complement rule here. But what two ways? I just showed you that. So I'll do this on the calculator. 0.2975. I'm adding this with this because that's the two ways you could not get your luggage. Plus 0.0075. And look, it's the same number. See, they match? So complement rule, disjoint, possibilities, outcomes rule. Okay? What's the probability you're on time and you don't get your luggage? On time and you don't get your luggage. So on time, no luggage. On time, no luggage. 0.77 0.05. Okay. Okay. Now, are they independent? So, so you know that right off the bat we know this is not independent. So you have to explain it really well or prove it mathematically. And the reason why is because getting luggage depends on the flight being on time. Does that make sense? Okay, you have a better chance of getting your luggage if the flight's on time. Okay, does that make sense? You have a better chance. What's the probability you get your luggage given it's on time? That's 95%. Okay, so what you want to do is using the formula, or you could use the formula. What's the probability you get your luggage given it's on time? Equals the probability of getting your luggage. Okay, so let's see. You can see it right away. This right here is 0.95. Okay, that's this one right here. Probability you get your luggage was this one right here, 0.695. So what did being on time do to the chance of getting your luggage? It increased it. You see? Let's just pretend this is 70, 80, 90, 95. So basically, you have a 25% chance, you have a 25% more chance of getting luggage if the first flight was on time. So they are not independent. It depends on if that flight's on time or not. Okay, probability you got your luggage given you didn't show up on time. So is that one of the ones that I set up? Okay, yes. This is the first event. This is the second event. That's our normal way. So that's right here. Okay, GL, OTC right there. And this is the toughest one. This is Bayes. Okay? So what's the probability you got your luggage? Okay, so that could happen two ways. This way and this way. So I already added those two right here. So the bottom is here, let me write it out the long way. So then you can see how it works and how neat it is. So look it was the way I got this was I added 0.1425, which was the way I got the luggage here, plus how did I get the luggage here was 0.5525. See, these are two events, two distinct disjoint possibilities. So I could add those two. Now look, what's the probability? Okay, this top one is the probability of on time and GL. With Bayes' theorem, the top is always going to be, it's going to be one of these two. It's going to be one of these two. Okay, so OT and GL is 0.1425. Okay, so that's just going to be, okay, I already know the numerator. Here's the numerator. That's this top one, which is 0.1425. Okay, let me do that over again. 1425 divided by, I already know the GL. If I add this and this, I get this number over here. I know I'm going fast. If it's too fast, just watch it over again. 695. Okay, so 205. That's Bayes' theorem. Okay, this is probably the hard. This right here and this right here is the hardest thing to do on tree diagrams. Okay, other than setting it up and getting the tree diagram. Okay, because like I said, a lot of people do this. They'll put OT here, and then on this bottom one they'll put get luggage. Okay, so you remember this has to be OTC. If something happens, it doesn't happen, and then you go to that. Okay, so I think this definitely went a little longer than I wanted to, but it's very, very good that you could be in one of these guys or girls at this. Okay, so thanks for watching and have a nice day.